Welcome to the deep dive. Today, we're tackling a core concept for anyone building distributed systems, something that comes up time and again, especially if you're aiming for, a senior software engineer role, remote procedure calls, or RPC. Think of this as your insider's look at how different parts of a complex system communicate, the crucial details you need to nail down.
Exactly. And this isn't just about knowing the definition, right? We're going to really dissect how RPC works, the advantages it brings, and maybe more importantly, the potential pitfalls, the stuff that can trip you up in real-world systems and definitely during those technical interviews.
Yeah, those interviews.
Our aim is really to equip you with a deep, practical understanding beyond just textbook stuff.
Okay, so let's get straight to it. For someone prepping for that senior level conversation, what's the essential way to think about a remote procedure call? Like the elevator pitch.
Okay, so imagine you've got this big application, right? And you've broken it down into separate services, microservices, whatever. RPC is basically the magic glue. It lets one service call a function or a method on another service, almost like it's just calling something in its own code.
Okay. So it hides the network complexity.
Pretty much. It abstracts away the fact that the actual code execution is happening somewhere else across the network.
So from the developer's point of view, it should feel kind of like calling a local function, even though it's miles away, potentially.
That's the goal, precisely. But, and this is important, there isn't just one way to do RPC. There are loads of different implementations out there, each with its own quirks and trade-offs.
Right. And I keep seeing the term schemas pop up when reading about this. Where do they fit into the RPC picture?
Yeah, schemas are fundamental for many RPC types. Think of them as a formal contract, like a blueprint. They explicitly define the structure of the data being sent back and forth and exactly what operations, what functions you can actually call on the remote service.
Okay, a contract. So both sides know exactly what to expect.
Exactly. And these contracts are often written in something called an interface definition language, or IDL.
Ideal. Okay. Got any examples that might click for someone in an interview setting?
Sure. A classic one is SOAP.
Yeah.
It uses WSDL, which stands for Web Services Description Language. That WSDL file is the IDL, and it spells out everything, the functions you can call, the data types for input and output, the message formats. It's super explicit.
So WSDL is like a really detailed instruction manual for talking to that SOP service.
You got it. And this explicitness, this detailed contract, allows for some really powerful stuff, like automatically generating client code.
Code generation. That sounds useful.
Oh, it is. If you have, say, a Java service with a WSDL, you can use tools to automatically generate a Python client library that knows exactly how to talk to it. No manual coding of the communication layer needed.
That's huge for interoperability, right? If you've got teams using different languages.
Definitely. It's a major selling point for schema-based RPC, like SOAP, or more modern ones like gRPC. But not all RPC works this way.
Oh, what's the alternative?
Well, some are more implicit. Take Java RMI, remote method invocation. It doesn't really use a separate IDL file. The contract is basically just the Java interfaces themselves.
Okay, so the Java code is the contract.
Essentially, yes, which means it creates a much tighter coupling. Both the client and the server have to understand the Java type system.
So with RMI, you're pretty much stuck in the Java world then. That feels like a big constraint, especially for microservices.
It absolutely is. Great for pure Java shops, maybe, but it really limits your options if you need Python or Go or whatever to talk to your service. But even with RMI, the core idea is still there, making that remote call look like a local one.
Okay, interesting distinction. Now, when we make these calls, how does the data actually travel? What's going on under the hood with serialization and networking?
Right, good question. So when you make an RPC call, the data, your parameters, the return values, it needs to be packaged up into a format that could actually be sent over the network. That's serialization.
Turning objects into bytes, basically.
Exactly. And the RPC framework usually dictates or strongly suggests a specific serialization protocol. Like a gRPC is almost always used with protocol buffers.
Protocol buffers, right. I hear those are really efficient.
Yeah, they're designed to be very fast, to serialize and deserialize, and the resulting messages are really compact. That's crucial for keeping network traffic down and latency low. The RPC framework handles all this automatically, serialization on the client, sending it, deserialization on the server. It's part of that abstraction magic.
Okay. And the network part itself, is RPC tied to something like HTTP or?
It depends on the implementation. Some are tightly coupled. SOP, for example, very commonly travels over HTTP. You can think of the SOAP message as the payload inside an HTTP request or response.
So if I'm debugging SOAP, I'm probably looking at HTTP logs.
Most likely, yes. But other frameworks give you more choice. They might let you pick the underlying transport protocol. You could use TCP, for instance.
TCP for guaranteed delivery.
Right. If you absolutely need to know your message got there, and in the right order, TCP is often the way to go. Think financial transactions, baby.
Makes sense. When would you not use TCP then?
Well, if raw speed and low overhead are the absolute top priority, maybe you can tolerate losing a packet here and there or handle it higher up the stack, you might choose UDP. It's faster, less overhead, but no delivery guarantees. So having that flexibility in the transport layer can be a key architectural decision.
Okay. Going back a bit, you mentioned automatic client code generation from schemas. Why is that such a big deal, especially for bigger teams or projects?
Yeah, this is where schema-based RPC really shines for productivity. With a well-defined IDL, you literally run a tool, and boom, you get client libraries generated in Java, Python, Go, whatever you need.
So developers don't have to write all that networking and serialization code themselves.
Exactly. It eliminates tons of tedious boilerplate code and reduces the chance of subtle bugs in how clients talk to the server. The generated code just knows how to do it, based on the schema.
That sounds like a huge win. What's the catch?
The main prerequisite is that the client needs that schema definition before it can generate the code.
Right.
Usually this happens out of band. The client team gets the IDL file from the server team somehow. They need that shared contract up front.
Right, so there's still a coordination step needed.
Definitely. Although there's an interesting outlier, Avro RPC. It actually has a mode where the schema can be sent along with the data payload.
Whoa, really? So the client doesn't need the schema beforehand?
Potentially, yeah. It allows for more dynamic scenarios, which is pretty neat. But generally, for things like gRPC or SOPT, you need that schema shared ahead of time. Still, the big win is that ease of making the remote call feel just like calling a local method. That's the core value prop.
Right, focusing on the business logic, not the plumbing.
Exactly. In theory, anyway.
Okay, in theory. That sounds like a perfect lead-in to the downsides. RPC sounds powerful, but where does it get tricky? We mentioned technology coupling earlier with RMI.
Right. Technology coupling is a big one. As we said, things like Java RMI pretty much force you into the JVM ecosystem on both ends. Client and server have to be Java-based, more or less.
Which kills the whole polyglot microservices dream, potentially.
It definitely throws a wrench in it.
Yeah.
If one team wants to use Python for machine learning and another uses Go for high concurrency stuff, RMI between them is, well, it's not really an option. Modern solutions like Thrift or gRPC are much, much better here, supporting many languages.
But even with those, the choice of RPC itself still imposes some level of coupling, right?
It does. And sometimes, like with RMI, it can inadvertently reveal how your service is built internally. Like, oh, this service must be Java because it's using RMI. Maybe you don't want to expose that. gRPC, SOAP, Thrift, they do a better job of hiding those internal tech choices.
Okay, so coupling is one issue. What about that local versus remote abstraction? You hinted it can be leaky.
Yeah, this is maybe the most subtle but dangerous trap. Making remote calls look local hides the fact that they are fundamentally different beasts. Local calls inside your process, super fast, negligible overhead.
Right.
RPC calls, you've got serialization, network latency, deserialization. It's orders of magnitude slower and more resource intensive.
So if a developer just treats an RPC call like any other function call without thinking,
they can accidentally build incredibly slow and inefficient systems. Imagine an API designed for local use, maybe with lots of small getter methods. If you just expose that directly via RPC, clients might end up making hundreds of slow network calls just to fetch the data for one object. That's the chatty API problem.
Ah, okay. So you need a different design philosophy for remote APIs, coarser-grained calls.
Absolutely. You need to think about minimizing round trips. And sometimes the abstraction is too good. Developers might not even realize a particular call involves RPC if it's buried under layers of code. Then they wonder why certain operations are mysteriously slow.
Interesting. Okay, you also said the network is reliable is a fallacy. That sounds ominous for RPC.
It's the cardinal rule of distributed systems. Networks fail, they drop packets, they get slow, connections break. It's just reality.
Yeah.
And RPC relies entirely on that network.
So unlike a local call, which pretty much just works or fails predictably.
An RPC call has this whole extra dimension of failure. Did the request even reach the server? Did the server process it, but the response got lost? Did the server crash mid-request? Is the network just really, really slow right now?
Wow, yeah, lots more failure modes.
Exactly. You have to assume network problems will happen and design for resilience. How do you retry field calls safely? How do you tell the difference between a temporary network blip and a real server error? What do you do if a call just hangs?
Right, that brings in patterns like retries, circuit breakers, timeouts.
All that good stuff. You can't just fire off an RPC call and hope for the best, like you might with a local function. The network will bite you eventually if you're not prepared.
Okay, that's a critical point. The last big challenge you flagged was brittleness, especially with things like RMI. What does that mean in practice?
Brittleness is when changes on the server side easily break existing clients, even if the change seems compatible. RMI, with its binary serialization and generated stubs, is notorious for this.
How so? Give me an example.
Okay, imagine our RMI service has a createPerson method, taking a person object with first name, surname, email. Now, the server team adds a new optional field, like phone number.
Seems harmless, right? Old clients just won't send it.
You'd think. But with RMI's binary format, even adding that field can change the serialized structure enough that older clients, which haven't regenerated their stubs, might suddenly fail when trying to deserialize responses or even make calls to the updated server.
Seriously, just adding an optional field.
It can happen. It forces this tight coupling clients often need to upgrade in lockstep with the server, even for supposedly non-breaking changes.
Ouch. That kills independent deployment cycles.
Totally. And it's even worse if you try to remove a field. Say that a person object had an old middle name field nobody uses. Server team cleans it up, removes it.
Oh.
Boom. Old clients that still expect middle name might crash during deserialization, even if they never actually use the value.
Wow. So technical debt removal becomes actively dangerous.
It can be, yeah. Or even just restructuring. Maybe you want to group first name and surname into a nested name object. That changes the binary layout, potentially breaking old clients again.
So you end up with these data structures that you can only ever add fields to, never remove or refactor.
Pretty much. It leads to append-only schemas and object bloat over time because cleaning up is too risky. You could use more generic types like maps or dictionaries,
Yeah.
but then you lose all the type safety and code generation benefits. It's a nasty trade-off with those brittle binary RPC mechanisms.
Okay, so given all these potential headaches coupling, the local remote illusion, network woes, brittleness, where does RPC actually make sense today? You still sounded kind of positive overall, especially about newer tech like gRPC.
Yeah, definitely. Despite the challenges, RPC is still incredibly useful. I wouldn't throw the baby out with the bathwater. The key is choosing the right implementation and being aware of the pitfalls, old stuff like RMI. Probably avoid it for new systems due to the coupling and brittleness, the COAP. It works, it's interoperable, but it can be quite heavy and verbose compared to modern alternatives.
Yeah. So gRPC is where you lean more often.
For many internal service-to-service communication scenarios, yes. gRPC hits a no sweet spot. It uses HTTP2, which is efficient. It uses protocol buffers for schemas, which are good for evolution. Well, better than RMI's binary blobs anyway. The tooling is generally pretty good.
And it promotes that contract-first approach.
Exactly. Which helps avoid some of the ambiguity. You get strong typing, code generation. It's well suited for synchronous request response, but you can also layer streaming or reactive patterns on top.
So the advice isn't don't use RPC, it's use RPC wisely.
Precisely. Don't let the abstraction fool you into thinking the network isn't there. Design your remote APIs, thoughtfully think about granularity, failures, evolution. Make sure you can update your server without forcing every single client to upgrade immediately.
What about client libraries? Good or bad?
They can be great. A well-written client library simplifies things massively for consumers of your service. But a poorly written one can hide too much or become another source of brittleness if it gets out of sync with the server. It's a balance.
So gRPC sounds like a strong contender, especially if you control both client and server.
Yeah, I think that's a key context. If you're building internal microservices where your teams manage both sides, gRPC is often an excellent choice. Great performance, good developer experience.
Where might it be less ideal?
If you're exposing a public API to a huge, diverse range of external developers using every language under the sun, maintaining official gRPC client libraries for all of them could become a significant burden. Maybe a simpler REST-JSON API is easier in that case. But for internal stuff, gRPC is very compelling.
Okay, this has been super helpful. So to wrap up, RPC lets services talk to each other, making remote calls feel local. Lots of flavors exist, from tightly coupled Java RMI to schema-driven SOAP and modern gRPC.
Right.
The big wins are abstracting network complexity and, with schemas, getting automatic code generation. But the dangers are real. Technology coupling, ignoring network latency and failures, and API brittleness if you're not careful with your implementation and schema evolution.
Couldn't have said it better.
Yeah.
Understanding those trade-offs is absolutely vital, especially when you're discussing system design at a senior level.
Yeah.
You need to articulate why you choose one approach over another.
Right. So for everyone listening, especially those prepping for interviews, think about it. If you were designing a new system today or looking at an existing one, what factors, performance, coupling, ease of evolution, client diversity, would you prioritize when choosing how your services communicate? That's the real engineering
Oh,
challenge.
absolutely. It's all about the trade-offs.
Excellent. Well, thanks for joining us for this deep dive into RPC. Lots to think about.